I want to share some experiences from my from my last years where we developed and engineered lots of apps in an industrial context, and born from these efforts is particularly the foundation of an association where we combined lots of companies with different competencies in order to drive to bring the industrial IoT and the so-called Industry 4.0 on the road, because many people experienced that only little or less companies can do these or realize projects in that field by themselves, and therefore companies develop partnerships, and our association is one of these platform where people connect and realize projects together. So, and from this, I think I can, or I think I got lots of experiences in these last years, and can tell you something about this, what I've seen so far. So, okay, here's a agenda for today. First, I want to introduce myself and give you also a short introduction into this association, and then I want to explain you what we or what our opinion is about industrial IoT, what we experience, what our perception is. And then I give you a sample, a real world sample that we developed by ourselves. And and then in the second half I will give you some insights in our app development technologies and approaches, and explain you our previous product, the Monkeyworks suite, more in detail. And I think the most important thing is to conclude this lecture here with some lessons learned. Okay, who we are, who I am. Thomas, thanks for the introduction. I received my PhD here in the university. It's now 8 years ago, and it was also in January. And then I founded the company Monkeyworks. Monkeyworks was a company where I took my research results and tried to bring it to the market. And this was the first entry point into the app technology. I had a model-driven software development approach, and particularly for the app development, to simplify the app development for automation engineers, for instance. But I will tell you later about this. Monkeyworks was taken over 4 years, 5 years later by a Chinese company, and then we got even more traction because in China, that's what I can tell you, people are more or people want more apps than Germans do. Everybody needs to be an app. They want to control their machines and so on, everything with apps, and that's different to the situation here in Germany. And this company, the Eco Industrie Automation, was a subsidiary of this Chinese company, and then I was continued my job that I did previously at Monkeyworks in this context. And I was really often in China because they wanted me to advise them in their development processes and so on, software technology and approaches. And 2 years ago we founded this association, and in the next month I will start a new job. So it's the last weeks with Elko, and so I want to get or approach new challenges in the future. Okay, therefore, if you want to contact me also at the end, I have also already my new email address. So if you have any questions, just feel free to ask me afterwards. Okay, the Marktplatz or marketplace in English is a platform where we connect companies and partners, and in order to advance the digital transformation in manufacturing companies. That is a big challenge here because there are lots of buzzwords and so on, and then people even don't know what they should do. In German we say they sehen den Wald vor lauter Bäumen nicht. Sorry, I cannot translate it. But we want to help them. We want to help these companies with our network and go to these companies, work out their economic goals that they want to achieve with the digital transformation. We are developing use cases. We share our use cases, our projects, so in order to inspire them and to so that they get new ideas, what they can do, and so on. And based on these use cases, we can also tell how they can, how it should be realized, and what costs are expected, and what benefits can be expected. So, and the last thing is that with the digital transformation, always new business models come along, and this is also where we have lots of experiences to develop new business models in the manufacturing industry based on the digital transformation. So what actually is industrial IoT, and where do we need mobile communication for this? And I brought you, can you read it? It's a pyramid, and this is a conceptual model in the automation field of automation, where you can categorize your services, your products, and so on. For instance, you have your production process, and in order to get the data out of the production process, out of the machine, and so on, you need sensors. You need this is with I/O signals, input/output signals, and these sensors needs to be connected by a field bus. These are real-time communication bus systems dedicated to connect these sensors and to bring the data into the next level, and this is a PLC. The PLC will control the entire process, will control the machine, and it's, how do I say, it's a special sort of a computer, real-time real-time capable, and and these PLC, all the PLCs together, we have in the automotive industry, in one production line you have up to 200 or 300 PLCs connected to each other, but also connected to a higher level system, and this is a SCADA. SCADA is short term for supervisory control and data acquisition. And that is yeah, the instance to bring together all the data from the PLCs and to get a view on the entire production line, so that the operator can see, okay, here my gate is open, and therefore I see the water flowing, and when the gate is closed, the water stopped, and he will see an alarm. For instance, the gate is closed but the water is still flowing, then something is broken, and he sees the operator sees then that, yeah, the details in this incident, which is transported by an alarm. So alarm is a very important term, and the MES is for production planning, and the ERP is it's a manufacturing execution system. It's for production planning, for resource planning, and so on. And the ERP systems, yeah, it's like an SAP where you have your stock and everything else, and everything is connected, but strongly hierarchically. So the data is going from one level to the next level, to the next level, and so on, and back again. So, and when you go from the top to the bottom, it's called, you control the process, and in order to control it, you need the data from the bottom layer. So now I want to show you some use cases for apps in these levels. So we have the production process. There, the operator at the machine, for instance, uses his smart device. I call it smart device. A smart device can be a smartphone or a tablet or another device with an RFID reader, for instance. It's used for order picking, for instance. You have materials with a barcode or with an RFID tag, and then you can scan it and say, okay, this is my right material, I have to transport it to the machine, for instance. Or you get an assistance. Assistance is very important because operators, the machines get more and more complex. So, but the operators are normally people without study, sometimes without higher education, and so in order to fix the most problems at the machines by themselves, they get, for instance, smart device, and when something is happening at the machine, they get information what needs to be done in order to fix this problem. That is a very interesting and currently also very attractive field where yeah, almost every machine producer or vendor is trying to improve these, or trying to develop such systems. Here are some other challenges. For instance, you never will find a production line with machines from one vendor. There are different vendors, and that's a big challenge, but nothing related to this lecture today. Okay, and then in the next level, and at this level, for instance, when you install such sensor or replace a sensor, such sensors provide you an interface, and you can connect to these sensors via a smartphone with a mobile application with an app on it, and you can configure this sensor. When something is not working as expected, you can run some diagnosis scenarios or some analytics on your mobile phone. You see the traffic or whatever, like in Wireshark for the other network layers. And for that use cases, the mobile applications are very interesting and will be used. All in everything related to to optimize the communication in this level, in this field bus level. Almost the same with the PLC level, where it goes to configuration. Normal PLCs or the new PLCs, for instance, Siemens is a big PLC vendor, has some interfaces, MQTT or OPC-UA. It's a great specification in the automation. And using these protocols, you can connect to the PLC, you can see the data, the information model, and the current values. And you can also run some diagnosis, you can monitor the operation of the PLC, and yeah, you can maintain it and also configure these PLCs. Very interesting topic also in the SCADA level. Here, this is the big red bell. That is, yeah, that will also be, how do I say? I will also explain this more in detail with in the sample afterwards. Alarm notifications. Alarm notifications is a very there's the biggest demand that made us with Monkeyworks previously very successful with lots of projects in this field, because using the push notifications from the smart devices, you can notify the right persons immediately when something is happening in your process, and then they can do something with this. And in China, we had a project at an automotive vendor, manufacturer, and they also tried to locate the position of the maintenance worker in order to notify that worker who's closest to the incident point, in order to decrease the time from occurrence to fix these problems, to the solution. So, and MES, it's rather process performance and optimization. You see how many pieces did what shift produced today, and you can compare to other shifts, to other days, and try to optimize then your entire production processes. And in the ERP, okay. Crashed. Na schön. ERP. Oh, das geht nicht. Jetzt. Da gab es einen Hänger. Ja. So, in the ERP level, you use mobile applications for order planning, for instance. You see what orders customers has or have placed so far, and when does your ERP system plan to produce it. So that is mainly, it's not a manual process to plan this, but you often get a call from your customer, when will my order be shipped? So, and then you open your application and see what's the current state, the production state, and when is the expected date to ship this order to the customer. So it's all about business performance, monitoring, and also operations. so you can improve your entire business processes at this level. So, and now we have this new field, this industrial IoT. And this industrial IoT makes it more complex. Because now you, or we don't have these strong hierarchical levels where you communicate only from one level to another level. Now you have sensors and other systems that immediately send their data into a so-called IoT platform or integration platform, industrial IoT platform, whatever. There are many names for this, and everything is connected in one platform. Yeah, you can leave out levels. It doesn't matter. You collect only the relevant data in order to realize your use case. So that makes it more complex to engineer everything, because you have to think very roughly about the required data and the information calculated from this data, and then how to visualize this. And here's a very that's this use case that we implemented at this Chinese factory, which I will introduce you in the sample afterwards. And here we get the data in order to provide the benefit to the maintenance workers. We collect the data from the field bus level directly from the sensors. We collect the data from an MES system and from an ERP system, put them all together, and have developed an app where the maintenance worker now can see where the incident is, what tools he or she needs to fix the problem, and how many spare parts are in stock, or if there needs to be reordered something, everything. Where he can find it in the stock, and so on. And all together in one application. So, and here, keep in mind, it's all about time. Time is money, and in this industry, in the automotive industry, it counts minutes. Minutes count. Minutes when the production line stays for a minute, then several thousand euros get lost. And every minute counts, and therefore we do such an effort to reduce the times. Okay, now let's come to the sample. And here you see this is a building plan from this factory, and I call it Gigafactory because it has almost the same size like the Tesla Gigafactory to be built in Brandenburg. It's 700 meters long and 300 meters wide. So you can see these dots are these dots are gates for trucks to deliver spare parts, also material. So okay, this is the production line. Here is the paint shop, for instance, and here the assembly lines. This is a big stock. And the maintenance worker now has to run lots of kilometers per day, and this has to be reduced. So So there's really much time required to solve issues. And I talked to the boss of this factory, and he said to me, my workers get a notification from the central control room. They get a notification in the central control room, in this SCADA system. And then they go to this place where the incidents occurred, see, oh shit, I have the wrong tools with me, and he goes back. And then he notifies, or he recognizes the spare parts are not available right now, and so on. He runs back and forth. They try to introduce, to reduce the times by using bicycles, but yeah, also not very effective. And what we did in order to reduce the time from the error occurrence to the error solution is that we are using smart devices. We are using smart devices for the notification, even on the smartwatch. So everybody knows a smartwatch, and that it vibrates at your wrist, and then you see, oh, there's a notification, and you go on this, or you tap on this smartwatch, and you see the first information. Then you open your app, and sorry. And you see the relevant data, what's required. So, and this is some screenshots from this app. You see here where the error occurred, and also with a short heat map, how many errors, or how many not following subsequent errors are involved, so that you can make a decision what error you will handle first. And you can see even before where this is exactly, and yeah, here I don't have some screenshots, but afterwards you see what equipment is involved, and what tools do you need, and then you also get a solution description. So where not where you get a small list of solution proposals, and also ranked what is most likely the solution to fix this error. And using that, we were quite successful to reduce the times with the app, and this is highly, it's used day by day by every maintenance worker, and quite a success. So, and what I told you is that in China people are more attracted to apps, to these technologies, and they also don't, they have, how do I say, they don't see that much risks. They rather see the benefits. It's quite different here in Germany. We are first talking about the risks, and then about the benefits. That's different. And in this factory, the Chinese, or the boss of this factory said, oh, what expensive will it be when I equip my entire factory with Wi-Fi hotspots? Why don't we use just the cellular network? It's all available. It's very good in China, and then let's open our IT and communicate via cellular network. Okay, and this is the deployment. So as I told you, we have here a cloud service, this IoT platform deployed as a cloud service, and here we have an edge gateway. So in IoT, you distinguish between edge and cloud. Let's explain this a bit. In the edge, you have also strong computers to pre-process data, and you just send maybe key performance indicators or some calculated information into the cloud and distribute it from the cloud onto the mobile devices. As an example, from these PLCs, I told you up to 300 PLCs in this factory. Only one production line had 200 PLCs. We implemented it in only one production line with 200 PLCs, and we have to analyze and aggregate 60,000 data points per second, and see if there's check if there's a limit value exceeded or below a limit value, and then derive an alarm from this if necessary. So, and that's what we did here in the edge, and we only forward alarms with all the information in it into the cloud, and then we send out a push notification to the smart devices, and the push notifications don't include all the plain data, just a reference, and when you open your app and are connected to the company IT, then you get the entire information. So, yeah. And now let's come to the app development for the industry. So from the previous slides, you saw that you need to meet some requirements. That is the connectivity, the most important requirement. You need data. You need data from the industry protocols, and these protocols are mostly proprietary, and there are some standards, and I call it OPC UA. That is the most important specification currently in this field. Then you have this Bluetooth or Bluetooth Low Energy to get the data from the sensors or I/O signals, RFID or QR codes for the order picking, commissioning, or also for the maintenance people to identify, now I'm at this machine, or is this the correct spare part to fix this error, and so on. And you have to get access to databases and other services. For instance, this ERP system to get the order, to get the place on the stock, and so on. Online, offline, big topic. In another sample here in the mining area in Lausitz, we had a project with previously Vattenfall, where we controlled the pumping stations for the groundwater regulation. And people had to go to each station and set the values, the desired values in these stations by them, manually, because there was no connection to other networks for the security reasons. And there we developed an app so that people can do it more comfortable, and but we had to in the office Wi-Fi network. We had to get the we called it also orders. We get the required set values from an geo information system, and then people go out, authenticated at this pumping station, and then the values were written into this PLC, restarted, and then everything was set as expected. Data analysis and evaluation with charts, lists, maps. Nothing to say more about this. Security is a big topic. Everybody, or there's a big joke that is telling the S in IoT stands for security. Everybody has a big fear for cybercrime and so on, and take this security topic very serious. Performance is a very big requirement, and when it comes to mobile applications, you have always to judge between how many data the amount of data to be processed, and battery lifetime, for instance, very big topic, and notifications. And I would say that with these notifications, the mobile applications got a big standing in this field of industry, because that's really new. Previously, people sent SMS and other or emails, and there you have all information either in plain text, or you have to copy something and open other apps, or that was a mess. And with this push notifications from the iOS and Android, that is really, really great. Okay, so let's talk about application fields. I think I talked a lot. This was the beamer is not so good here. This was the app for the pumping stations at Vattenfall, and here we have we always told that we want to integrate the offline things into the Internet of Things. That's what we did with these apps. Using these apps, we got all the information from the pumping station, which are not connected to any network, and we got the information from it and carried this information into the central control room. And once we arrived there, using geofencing and other means, we were able to automatically synchronize these data. Once they arrive at a certain Wi-Fi hotspot that was marked as a geolocation, then transfer was done automatically, alarming and notification. And in the higher levels of the automation pyramid, you want to see data in relation, production to energy consumption, for instance, or compare the performance of shifts or teams to each other. And that's where people want to create their individual dashboards. Everybody wants to see different data. And people came to us and say, okay, we person A needs that dashboard today. He has this task, and 2 months later, he has new responsibilities in the company. Now he needs a different view on this data. How can we handle this? And we have some ideas, and I show you later. But that that were real questions that people asked us. Yeah, and then this assistance, guidance, and documentation, also a big field. So now to the challenges. And yeah, the first challenge is that you have to yeah, maintain lots of devices. You start with the two operating systems, iOS and Apple, and then you have different smartphones, you have tablets of different size. Yeah, now you have something in between called phablet, and with yeah, each technology, each operating system, you have to use different tools and different technology or SDKs, and you cannot just use a smartphone app on a tablet. You have to always to re-engineer everything and recode and so on. That's a big challenge. And then yeah, using the App Store, most apps in the App Store cost 99 cents, and then when I told my clients, okay, when you want to have this, it costs 150,000 euro, because two people are working 2 years on it. And then they ask, hey, when I go into the App Store, I see apps that I never saw an app that costs more than 20 euro. Why is it so expensive? Yeah, that's because these individual use cases. I was able to explain it because nobody else uses this app. When I can sell your app to 1,000 other people, then I can also do it for 150 euro. But yeah, this is because of the individual use cases. You have, or yeah, even in one company, in one production line, you have different use cases, and you develop apps that only use 5 to 50 people, not more, and that makes it so expensive. And also challenging because you need software development experience and competence in the company, and then you have this device and technology diversity. Everybody wants to use their own devices, or then in a company devices are used 3 to 5 years, and then you get also new devices, and you have a mix of Android 6 and 10 and whatever, and yeah, this becomes a mess in some point. Yeah, then you need different programming skills when you want to develop an app. You have to deal with Objective-C or Swift or Java, or Kotlin, or whatever. You have to deal with iOS, Android, the SDKs, NDKs, and yeah, the people who developed applications in this industry field are mainly C or C++ developers, some Visual Basic experiences, and now they should create apps. That's a real problem. So, and then this data privacy and data protection. Yeah, that's always the first question people are asking. What's happening with my data? When I use a Google or when I use an Android smartphone, everybody can read my data. That's also always that yeah, statement from our clients, and then you explain them not every data, and you have the control over your data, but you have to be yeah, there have to be a sound engineering behind, and then everything is fine. Then you can do it with encryption and cryptography and so on. Everything is possible. but it will cost more money. 99 cents. Okay, and one of another challenge, and point 6 was also mainly a roadblock for our software previously, the app deployment and distribution. When you want to roll out a mobile application in an industrial context, only to 50 devices, not over the public app store, then you have to deal with lots of barriers, certificates, memberships, and also tools. We'll go to this point later, and but that was always a problem where we hopefully found a solution. Okay, but despite all these challenges, we had one vision in our company previously, and this vision was that apps need to be throwaway products. So you have a use case and a task. You go into an app store, you look what app can help me, you install it, and then when your task is done, you throw it away. You can look into on your smartphone a study from 2015 or so, and the time said that people normally, on average, have 90 or 95 apps on their smartphone, but is using only 5 to 10 regularly. So the other apps are only, I want to test out something, I want to see, I want to book a trip, and after that trip, you never use this app again, and so on. And that's also what we want to have in the industry. Now I'm responsible for this production, or for the production of a certain car model, and when this model is not being produced anymore, or when production line has been constructed, then I don't need my applications again, because I'm responsible afterwards for another production line or for another product, than for commissioning fruits or whatever. So, and then I have different apps on my smartphone, and that's the vision. And another point is that the app development should be so easy that everybody can do it without programming skills, and just collecting my widgets, everything what's needed, and then say, okay, that's what I want to have on my smartphone, and then cling, it's on the smartphone. We're very close to this vision. But we had a long journey to come into that direction. The first was that we should have a look at all the different development approaches, development technologies, and so on. This is in German, unfortunately, but I will tell. So you can see or compare within the mobile app development, you can compare the cross-platform approaches and the native approaches. That's the first thing. When it comes to native, you have, as I mentioned, to deal with different operating systems, different versions of these operating systems, and so on. But you have all the power that your device provides you. There's nothing what you cannot do with this piece of hardware. And then in this cross-platform approach, in this you have the mobile web applications, the hybrid application, which is a combination of web and native, and you have generative approaches with model-driven software development, or where you transpile. Transpile means you have one programming language and you transpile, you generate, or you convert it to another programming language. And that's what, for instance, TypeScript is doing to create JavaScript. So, and now I want to go a bit deeper into these native, hybrid, and web to compare. Awesome. The native apps. In the native app, you develop your application right on a mobile SDK, which is on top of the mobile operating system, and where you can use functions right from this mobile operating system. Right out from your native app, you have file and database access. You can use arbitrary IP-based protocols to include external services, or also third-party services. You can develop your own protocols, or no matter if they are binary or text-based, or you have everything in hand, but you have to do it always for iOS and Android separately, and do it by yourself. You need a very big programming skills. So, and then you have this mobile web app as the, right on the other side. You are using a browser, and you are limited to the browser functionality, or to the interfaces that browser provides you. And let me go back. These arrows show the communication direction with the mobile operating system. So the operating system can tell you when an event occurs, and you can access sensors, positioning sensors or whatever, directly from the native app. And that's different in web apps. In web apps, you are limited to the notification from the operating system. So that works also with the positioning sensors, but the positioning sensors will notify the mobile web application only when the position has been changed. So it's a changed event. And another point is that you are limited to the HTTP or HTTPS protocol. So the web protocols, and when you want to include third-party services, you have to do it by a proxy, because you have the or you are limited to the same origin policy. You can only call or invoke services where you initially get the JavaScript or HTML files from. So that's different. And then there's a hybrid approach that should bring together the advantages of both worlds. With the hybrid approach, you have such a native app container with a native lib, and this native lib will now ensure the communication with the mobile OS. Then using this an embedded browser, you can develop a web app that has native a native feeling and uses native functionality. And then you are not limited anymore by the same origin policy. You can implement arbitrary IP protocols, but that's not possible in JavaScript. When you want to implement those protocols, then you have to extend this native lib. That's possible, but you have it do also in the native language. That's the trade-off that you have to do. Yeah, but then you have the same possibilities with a native app. So the development effort is somewhere between the native and the web application. And then a fourth approach is the model-driven app development. So a model-driven approach where you have a model. A model is a description of a certain subject matter, let me say subject matter. This model conforms to a media model. So, and this media model now defines what entities do I have and what relation does it, or are these entities to different entities and so on. And yeah, based on this media model, you define your model, which is an instance of the media model. And such a model, yeah, it's a descriptive approach, and it can be compared maybe to an HTML. HTML, it's also some sort of an XML description where you say, okay, there should be a button, and this button should do or should get the description button 1 and the text click me, and when I click it, a certain action will be invoked. So, and when you don't mix HTML with style sheets, then you have just a description without any styling and without any implementation aspects. And then you put this model into this into a browser, and the browser will render this model. It's completely the same, but what we did is we use such a generative approach where a model will be read by a code generator, and this generator produces code. So we want to create an app. And we had a look at these hybrid approaches with this native lib, and we also created such a platform-specific library that can be used in each app. So, and the code generator now only produced instantiation code. This library can be seen as a framework, and the code generator generated the instance classes and put them together, and then this app was born. So in my PhD thesis 8 years ago, I generated the entire source code, but then we thought about what is always the same in each app, and then we excluded, or we extracted it into a library that is being used in each app. Yeah, so that's the generative approach. And there are some limitations, but first let me compare them again. As a summary, we have this native, web, and hybrid. You can see with the native app approach, we can realize everything from our requirements list, and with the hybrid app, almost everything, with some exceptions here. And these circles mean that when you extend these native libs, then you will get also here a plus, but it's not from the beginning on available. So yeah, and you see the web application is not very or cannot meet every requirement, almost no requirement, and yeah. So now I want to come to our own approach, and to go to it. I want that you remember that our that the task that I have to do with my app is in the focus. So that's the very first. What do I have to do with my app? That's the question. So, and based on this question, I ask myself what I'm supposed to do with the data, and which view I have, or which view on this data will support me in my task. How do I have to visualize the data? And then what information has to be derived from this data so that I can meet my task. So, and when I have answered me these questions, data, where does it come from, what information do I have to extract from this data, then I can go into, or then I can look for an app. And that is not, can you see this?
Yes.
This should be here an App Store symbol. And then to come to this vision, I will go into the App Store, in some sort of an App Store, and look for this application that will help me in fulfill my task, or get my task done. And that's what we tried out. We created such an enterprise app store, and we call it HMI store. HMI for Human Machine Interface, it's a general term in this domain. And people then were able in this industry to see the apps that are available, and were able to install it. Everybody can see all apps, and then when they have a certain task, they were able to look into this app store. And that worked. And then we had this gap from the model to the app store. And that's what we, this gap, we filled it with our own tool, and I want to introduce it after this interim conclusion. So, the idea is we have iOS and Android devices, but it should not be relevant for any decision. I want to meet a task, I have a smartphone, my colleague has another smartphone, and we have to do something with our smartphones, and we don't care. We want to meet these tasks at hand. And ideal, I can also design my dashboard by myself, because I know what data I need, and I know how I can work best with this data. We have some tools that make it this possible. For instance, more and more frameworks emerge, sometimes out of nowhere. And we have new tools with new development methods. We have this cross-platform approaches. We have generative approaches. We have lots of templates, even AI, what role AI plays. I will also tell you later. And then we have lots of different technologies, and yeah, how can we use it, and where are limitations? And yeah, here I will show you our experiences. And we created an application, and we called it the Monkeyworks Suite from the Monkeyworks company. And our mission was that to create an app should be as easy as creating a PowerPoint slide. So that was our vision or mission, and for that we created such an app designer, and in the background this model was filled. It was everything held into a big model, and yeah, then what to do with this model. We have these code generators. The code generators generate code, and our customers said, okay, now I have a directory with lots of files I cannot read, I cannot understand, and I don't know what to do with this. Yeah, you have to compile it. For an iOS app, you have to look where you can find an Apple computer, install Xcode and all the SDKs, and then you can compile it with Android, or you have to download Android Studio, and then you can load it into Android Studio and compile it. They were not so amused, and they say, okay, no, it's too complicated. It's too complicated. So we developed then a service for this. So the model then will be transported into a cloud service. Yeah, it's a bit continuous integration and so on. There's no magic in it. We put it into this cloud service, and then the customers were able to download their IPA or APK files, and then also put it into this enterprise app store. But they then complained about all these certificates and so on, and yeah, something for the lessons learned. So people now go into this suite, design their apps, press a button, and then the model will be saved and transferred into this build cloud. Then yeah, either they are connected to a store directly, then it's pushed into the store, and it made pling after 10 minutes on their devices. And that's not a lie, that really works. And or they were able to download then the files and also put it into the public app store or in their own app store. With Android, you have the advantage that when you have an APK, you can put it to any device. With Apple, you have some more limitations. But yeah, how does it work? Yeah, as I say, we have this model, we have these transformational rules, and we put it all together in a generator, and we receive these runtime artifacts. And this is hidden behind this tool, the model and the generators, and partly in the cloud. But at the end, you get the runtime artifacts, and that were previously the bunch of source code files, and then the compiled executables. Yeah, That's under the hood of this tool, just to categorize it. And yeah, what makes it possible, and that was several years research work to create a so-called domain-specific language. In comparison to a general-purpose modeling language, a domain-specific language is dedicated to a certain subject matter. So you have a problem at hand, and then you create your model entities by yourself, the model constraints, and the model visualization. And that can be seen in this sample. You can such a family tree. You can use UML as a general purpose modeling language for this, and then you get it very complex, and you have always rectangles, and using such brackets, you see the type of these stereotype of these rectangles. That's not very usable. And therefore, with the domain-specific language, you use only a subset of this general-purpose modeling language. You create a new visualization for your model entities, and then you get maybe something like that. That you have a circle for female and a rectangle for male, and such a how's it called? Raute, for animal, and you see then at a glance what this model will or is supposed to do or to tell you. And that's what we did in this, or what I did in my research. During my research time, I took all the use cases that we had in the industry, and derived a big meter model from it, and put it into this tool. So it has more than 1,000 classes and references and so on. But when I go back, that's nothing what the engineer is seeing. He only works with that interface, which he is familiar with. Okay. So, and here such a or just a word for our technology stack. We created an Eclipse RCP application, and with the modeling extension, and we used the eCore and EMF tools to implement our meta model, and the code generation is in the second development stage, has been moved completely into the cloud, including the build system, and then the Enterprise App Store, which is also just an app, and is downloading the IPA or APK files.
How is the logic of the application model?
Good question. The logic is also each element on the app, what you see in the app has a representation and an animation and an interaction. So, and using the animation, you can define what should happen, or how should this element on the UI should behave based on certain events. So that's what you can describe.
Okay.
So, and when you want to go deeper and to create more logic, then I want to refer you to the lessons learned. That was, yeah, there I have another approach or an extension on it. Yeah, and now another interesting aspect, the context of use. The context of use is where do you use your smart device and what task do you want to achieve and what device are you using. So it's a combination of device, of task, of environment. And here you see the difference between a smartphone and a tablet. It's the same application. And using a smartphone, you have limited space on your screen. And therefore, you need a different representation of your app. What you have here in a big map or plan of your production line, where you see also the relation between your machines and the handover points. That's what you only have here in a list, in a flat list, and where you cannot see the difference or the relation between the machines. And that's that needs to be kept in mind, because when people say, okay, we just develop one app and then we zoom in and out, then you will come to a point where your fingers are too big, too different, or to press the right button, for instance, or where you have good chances to do the wrong things. And therefore, you should always think about your clients, about the people who are using a certain device, what they should do with this, and when they need to see the production line here. For instance, here is an alarm, and this machine has an error. So, and this machine is not working anymore. And why is it not working? You go into this machine and then you see, the machine in the line after myself has a problem and don't accept more material, and so I have the buffer between the machines is full, and then I see, the next machine is this one. This one has a different error, and then I go to this machine and fix it first. That's not what you see at this representation at a glance. Just an example. It's a very simple example, but you should use the different sizes, and you should use it wisely. Another sample is where you use a smartphone. You have your smartphone in your pocket, and it rings, and or you get a notification on your wrist, and then you take it out of the pocket and see, okay, something is not working. There's a pressure that is too high. Okay, I have to do something with this. But then you maybe go use your tablet and go a bit deeper into the data and do more analysis, because here you have the space to use big graphs. You can zoom into it and utilize the data at hand more efficiently. So, and this is what we also wanted to keep, or to where we want to help the engineers, and we created a self-learning algorithm. It's patented, and what we do here is we try to reorganize the model, and based on the platform and the context of use that's written in such a platform model. And we have adaptation rules. It's rule-based, and we calculate then a proposal. So maybe you have you modeled a tablet application, and then you say, okay, now I want to have it on a smartphone. And when this algorithm sees something like that, there's something that looks like a list, then he or the algorithm transforms it into such a flat list, and moves out all the other elements, the elements in between, or the elements which does not provide any data or any new information will be removed, and then it creates a proposal. And this proposal is shown into the application, and then you can say, okay, I completely accept this proposal, and then you have an adapted model and smartphone and a tablet application. You can say, okay, I completely reject it because it's crap, and you can say, okay, I will modify it. I modify it because I have some preferences, and these preferences then will be stored also again in this adaptation rules, and with each step, with each iteration, your algorithm gets smarter and smarter. Yeah. So, last thing is lessons learned. And the first point is that the biggest lesson that we learned is that we, because of the many use cases, many application fields, and so on, many specific requirements, in each factory you have different protocols or variants of it, and we had to put very high effort in updating the model and the code generators, which as a consequence had influenced our delivery process and made that even more complex, backward compatibility, and so on. And what we did is, and now it comes to the logic, we combined the model-driven approach with a programming language, where we provided Golang an environment in this tool, an interface to the model, and then you were able to implement your specifics from your specific factory with the Go language, and Go will be compiled to C and or to binary code, and not to C, to a binary code that can be loaded in iOS and Android same. And that's what we did, and with that and with the workbench, we were only able to meet 80% of the use cases or of the contracts. And for the rest, we had to develop it by hand. So that's, yeah. And then I mentioned the app distribution. This is a cycle. You have this. You have an idea, and you have a software developer who provisions your app after compilation, packaging, and upload into a store, and a customer wants to buy these apps. Volume licenses is a big topic in the industry, and then they have to distribute the apps. So the first point is that the one who buys the app is in a company, not necessarily the one who distributes or who uses the app. That's different to meet this challenge using the normal app stores. And then you want to get back your feedback. And the app distribution, here when you want to provide it into the store, you have to be an Apple developer, Google developer, you have to create certificates and also provisioning profiles and so on. That's too hard from our experiences for our customers to do. And what we did is, I just skipped one slide. What we did, this is the last slide, is we looked at a very successful company, Tencent, with WeChat. WeChat is on 90% of the Chinese smartphones, so it's very, very popular app. And WeChat is not only an app, it's an ecosystem. And they have so-called mini programs in it. And that concept did we use. So we created one app as a container, so to say. You download it from the App Store, install it, and then from our tool you can scan a QR code, and then using this QR code you can load your mini program. And this mini program can then do something very specific, and it's a combination of an app store and a small app store and WeChat. So and this is what we are, what is the next big thing at Elko, not with me anymore, but that's what we are going to release in the spring. And then maybe when I will be invited next year again here, I can tell some experiences about this. Okay, thank you. Any questions?
How do you handle the back-end services? Because the front end is very beautiful. What language or frameworks do you work with the back-end?
So we created a back-end. We have two approaches. The first approach is we call it Lean app. The Lean app is able to connect via an automation protocol